Thank you, Laure, for the overkind introduction. Hello, everybody. Good morning, good afternoon. I'm presenting you, as mentioned, the current state of research in sound stimulation therapies in tinnitus. I'm currently moving between labs, which is hindered by the pandemic situation we have at the moment. But I want to basically give you an overview what is currently done with respect to acoustic stimulation in tinnitus. So I branched it out for three main aspects of it. The first aspect is the acoustic short-term tinnitus suppression, so-called residual inhibition. The second aspect is the widely used masking and habituation approaches. And the final branch is sound therapies or acoustic neuromodulation. So sound therapies which are building on reversing maladaptive neurophysiology, which is caused by tinnitus. The acoustic short-term tinnitus suppression is a phenomenon which is known since the early 20th century. It was discovered accidentally by Spalding. So after presentation of an acoustic stimulus, usually a noise for at least 30 seconds, the tinnitus is suppressed, so the perception of tinnitus is reduced or even completely gone for some seconds after that stimulus is offset. It has to be presented at a certain sound level, usually standardized, it's somewhere above the minimum masking level of tinnitus. So it's the loudness noise has to have to mask your tinnitus, so you don't hear it internally any longer. The response after the tinnitus is offset, what you see here on the side is usually of a sigmoid shape, so it's some nonlinear response. So you have up to full suppression right after the sound is not presented any longer, which then grows back to your normal tinnitus perception over time. There's different shapes, there's different lengths of these responses depending on the individuals. Some individuals don't experience this residual inhibition at all. Over studies, it's somewhere between 50 and 90%, also depending on how exactly it was stimulated and so on. Around 5% that has been described also for a long time now and summarized in a recent publication by us. Around 5% even experience a prolonged suppression, up to days even. So some minutes of stimulation can even lead to days of full tinnitus suppression in rare cases. There seems to be in our pool studies at least, and some anecdotes from other studies, there seems to be a better response in women. We also looked at possible influences of psychological aspects and or personality, which we find none. So it remains, or the current conclusion is certainly that we'll have to look at some neurobiological responder subtypes or phenotypes. It has been tested here and there as a possible treatment, but hasn't established itself because it's a short-term phenomenon, and it's mostly used in basic research up to this day. Mechanisms of action, just quickly, has been theorized that it's a reinstantiation of the normal feed-forward inhibition. If you present sound to the ear, feed-forward inhibition will take care that yes, hyperactivity is suppressed, and there's hyperactivity related to tinnitus, and thus it's not heard any longer. Animals models or theories look at the firing rates in the inferior colliculus, so in your ascending auditory pathway. It's one of the stations basically up to the cortex, where it has been reported, especially in animal data, that firing rates are increased after peripheral hearing loss. And it has been shown that presentation of sounds suppresses this spontaneous firing rates for some time. And also looking at here, you also see some kind of suppression response, which grows back, as we have seen in the slide before. On the cortical level, some studies have been performed. An original one of Kalbok and Weiss in 2008 showed that in the phase of your tinnitus suppression, the delta is normalized, meaning that the delta oscillations in MEG or EG signals are normalized to a non-pathological state. In a recent study of our group, we also saw what you see here in this figure, that the maladaptive neurophysiology, which is this, what you see here in red, this decrease in alpha oscillations and increase in gamma oscillation, can be, in this phase of the suppression, can be inverted in the responders. So people with at least 50% of suppression have an inversion of this maladaptive pattern, which also can be social localized in the auditory cortex. Then for masking and habituation, it has been around since the 70s, basically, has been iterated through the 80s. There's some major concept in it is the so-called energetic masking versus informational masking. It can be summarized as bottom-up energetic versus top-down approach, the informational masking. So the energetic is just putting energy on your auditory system, which then basically kind of overrides all maladaptive physiology, whereas the informational masking is rather that you are in your consciousness or your awareness of sounds and of tinnitus are kind of distracted, or your attention can be moved to other sounds. And another aspect is total versus partial masking, and the critical issue of the mixing point. What you see here on the side is we have on the x-axis the sound level presented, the sound is presented, and the y-axis the effectiveness of the habituation. You see that the mixing point is actually the peak, so where the tinnitus and the masking sounds have basically the same loudness, and under this mixing point you can hear the tinnitus very well, and over it it's fully suppressed, masked. So tinnitus retraining therapy uses this concept of basically presenting sounds under the mixing point, and different iterations of masking and this habituation approach played around with these mixing points. There's still inconclusive results and recommendations, but it's widely used in practice to this day. So the mechanisms of action are mostly on the perceptual and psychological level. Some kind of feed-forward inhibition in energetic masking, as seen before with residual inhibition, is certainly there, and it has been shown in a human neuroscience study that, again, akin to the residual inhibition, the delta band, the maladaptive delta band increase can be inversed during masking. So now for the third part, the sound therapies, or what I call the acoustic neuromodulation, which really target this maladaptive neurophysiology. So the stimuli are usually tailored to the hearing loss edges and tinnitus pitch. What you see here in a nice overview from Lorena, 2015. And the upper panel in A you basically see a schematic of a hearing loss. So you have no hearing loss in the lower frequency, and then in the higher frequency, the hearing loss starts. In B and C, you have two approaches from Laure et al., which is quite old. They used frequency discrimination training around the edges of the hearing loss. So it's a perceptual training, and engineer et al. They're using presentation of random sounds around this hearing loss edge frequency, which is then also paired with a vagal nerve stimulation, which is in fact bimodal stimulation. So combining acoustic with electric stimulation. And then what I'm going to look in more detail now is the D&D, the approaches of Pantev and Tas et al. Just quickly, Testament also tried out to increase the input on high frequency hearing loss in some studies, but oops, sorry, that was not planned. But most importantly, we now look at the two most prominent approaches, the acoustic coordinated reset neuromodulation, developed in Jülich by Tas and colleagues, which basically aims at a desynchronization of the pathological delta activity by random presentation of sounds around this tinnitus center frequency. And the, really sorry, the delta desynchronization is then induced by the frequency these sounds are produced, which are in the range of delta, so somewhere between 1 and 4 hertz. The other approach is not using this temporal aspect of sound stimulation. It's using basically the frequency, the audible frequency range, and modulates the frequency aspect in that it filters out the the energy or the sound spectrum around the tinnitus frequency. It's aimed at counteracting the hyperactivity in the tinnitus frequency in auditory cortex by lateral inhibition. So when you filter out the sounds around the tinnitus frequency, neighboring neurons are activated, whereas the tinnitus frequency is not activated. So the neighboring neurons exert lateral inhibition on the tinnitus frequency neurons. And like this, it is theorized that basically the wound is closed somehow, which you have around the tinnitus frequency, and therefore tinnitus should disappear. There has been several trials. I think it was 2017, 8 publications of the acoustic coordinated reset neuromodulation. At MCHIC 2014 looked at EEG of these trials, and they could show that indeed, again, there is a reversal of this maladaptive neural signature, which you see here on the side. You have again decrease in delta over time, decrease in alpha, and decrease in higher frequencies. Also nicely source localized in and or around the auditory cortex in temporal regions with some other critical regions of the tinnitus network. It's a safe approach, but still there's no clinical recommendation for it. And in the review of Wecker et al. 2017, it is also concluded that basically the theory is unproven with respect to the desynchronization of the delta activity. The last control trial of the Tailor-Made notch music training was performed somewhere around 2016. It was just behavioral, and no effects were found for the tinnitus questionnaires. And there was a reduction in the self-reported tinnitus loudness in the treatment group, which you see on the side in the lower figure. The approach pops up here and there, and it's commercialized by third parties, whereas the approach of Tass and colleague is commercialized by themselves. Yes, these are the two most prominent approaches. Due to time constraints, I made a cut here, and you can still ask me about further concepts, but for the time being, that's all I'm going to present. What's also very important is the tinnitus matching. So for many of these approaches, the tinnitus has to be matched with respect to the perceived pitch and loudness. Several approaches exist. We also performed a comparison study 2019. These approaches can be summarized in algorithm versus user-driven approaches. Algorithm approaches, they present you with options where you have to choose, like in the method of likeness, how alike is the presented sound to my tinnitus with respect to loudness and pitch. Or in the two alternatives forced choice method, you have to basically indicate that the presented sound is higher or lower than your perceived tinnitus sound. And the bracket algorithm narrows the search space to the point where the tinnitus pitch is identified. A user-driven approach, like the methods of adjustment, is just making use of devices where people can adjust knobs or sliders to find and match the tinnitus frequency. There's acceptable reliability of all approaches, meaning that people are usually able to match their tinnitus pitch in several runs, more or less to the same frequency. Validity, so is this really representing the true tinnitus? This question is kind of unresolved. Also to this day, there's not really an objective way for tinnitus matching. So you always rely on self-report of any in any form. It's highly time consuming. So we had a speed limit, time limit in our study where we aimed at doing a whole matching and audiometry session with 5 matching runs in 1 hour. So time consuming, and it's also highly depending on training and expertise. So our people, musicians, that helps a lot. And some people have issues in differentiating between pitch and loudness. So if the sound gets louder, they can think that it gets higher in frequency or vice versa. So it's really also highly depending on the expertise of the participants. It's ongoing research still to this day. There is some consensus on key aspects, but there's no standardized methods. So one of the consensus is that you should do a separate pitch and magnitude loudness assessment, that you should test for octave confusions. So is the final matched tinnitus pitch really in the right octave, or is it one below or one or more above? And also some consensus is here about the testing side in the ear, that you should mostly start with the contralateral ear to your tinnitus or the good hearing ear. So the resume, no magic bullet sound treatment yet, as with the presentation before. Same but different. Some alleviation, some habituation. So really no official recommendation, like in a recent clinical guideline for any of the presented approaches. So the classical paradigms of acoustic neuromodulation are presented are somehow on hold or discontinued. Here and there, some publications pop up. And yeah, one can ask, is this kind of the end of an era? There's a pragmatic use of maskers and habituation as a psychotherapeutic or therapeutic tool. And as asked before, what are we really targeting? Also with these treatments, are we merely targeting the auditory phantom perception or presence of this tinnitus, and or also targeting the tinnitus disorder, so the tinnitus related distress and so on. And this is what you nicely saw also in this slide, so figure 4 would be the tinnitus questionnaire, would be the tinnitus disorder, and figure 5, the self-reported loudness, would be basically the auditory phantom sound. And you will also, there will also be a talk by Hubert Lim about bimodal stimulation, so I will skip this. And it can be summarized that at least, even if they're not highly effective or specifically effective, they're relatively safe, mobile and self-reliant, low-cost approaches, which is also reflected in the self-help, let's say, scene or community. We did an analysis on the Tinnitus Hub data in a survey they did on what treatments are applied, and you really see that the self-sound stimulation is the strongest node here with a lot of connections. And we also see notch music and acoustic neuromodulation, sound cue, neuromonics, and so on, masker are also all there. So skip that and just jump to the review of tinnitus apps we did into 2020. We identified several apps for tinnitus treatment, and if you look at the subset there of tinnitus therapy, out of these 24, 18 are sound therapy, and sound therapy is also in there, and notch therapy, so we have about 20. And so on, and masking and habituation. So almost like 3/4 of all apps you find in all the app stores are some kind of sound therapy or treatment for tinnitus. We then also rated these apps with respect to their soundness in a scientific sense, and only saw that around 4 of about 60 apps match these criteria. So we should really, as I said before, we should iterate on the basic research, do proper replicated incremental science. Maybe we should also talk about core outcome for sound therapies as it's done. For general tinnitus research, so what are the parameters, what are also the outcome measures beyond just questionnaires, identification of neural subtypes, also genetics, bridging animal versus human research, very important. And in general, not only for this, it's just the scaling and biobanking, big data efforts, which should allow for more insights. For me, scaling of sound therapy research could be done via online tools like an online self-test platform or apps. I already co-developed an app with Tinnitus Hub, and there's also the mentioned app Shades of Noise in the Unity project, and it all aims at some customizable sounds and treatment protocols which can be individualized, and thinking of some creative ways to close my talk here. Is one can think of generative music. So you can take all these parameters, frequency, filters, temporal modulation, and so on, and make computer-based generative music, which is basically generated on the fly. So you don't have just the boring, simple noise sounds and so on. And you really can start working on an aesthetic appeal. But on the other side, generative music, which is mostly electronic, is maybe not in everybody's taste. Yes, with that, I want to close, and thank you for your attention, and thank you for all my current teams, and I'm happy to answer your questions.